So hello guys, welcome back to my channel. Today we are again solving the LeetCode problem of the day. Today's problem is best time to buy and sell stock using strategy. So I hope you have read the problem. We'll proceed with the solution. If you haven't tried, then I would advise you to pause this video and then do give this a try. We'll begin now discussing the problem. So according to the problem, we have been given two arrays. First one is prices and the second one is our strategy. According to the problem, we can only have three of the strategies, either -1 or a 0 or a 1, right? So if my strategy is -1, that means that I'm buying a stock on the ith day. If my strategy of I is -1, that means I'm buying the stock on the ith day, and so my overall balance will decrease by the price of I, right? If I'm buying a stock, then I would have to pay the price of the stock, right? So I'll do a minus of prices of I on the total sum, or total profit, because I'm buying the stock. If I'm holding the stock, then I'm doing basically nothing. The overall profit remains as it is. If I'm selling some stock, then I'll add that value to my answer, or I'll add a prices of I to my answer, because I'm selling that stock, right? So this is basically the strategy. It could be either of these three things, right? So we have been given prices array and strategy array. So I'll take an example. If my prices is 3, 4 and 2, 4, strategy would be -1, 0, 1 and a 1. This is for day 1, day 2, day 3 and day 4. So I choose to sell the stock on the day 1. So I'll add -3 to my overall profit. Now plus I'll get the total profit. I choose to hold the stock on the second day, so I do not get anything. So I'll add a 0 on the second day. I'll move on to the third day. I choose to sell this stock, so I'll get the profit of 2. So I'll get a profit of 2 here. Plus, I choose to also sell the stock on the fourth day, which has a price of 4. So I'll add a 4. This is -3. This is +4. This would be 1, and then this would be 3. So my overall profit is now 3, right? And now again we have been given one more parameter in this problem, that we have been given a k, and we can perform at most one operation. So according to that operation, we can, if we choose to perform an operation, then we have been given a k, that is k is even, right? We've been given a k. We can choose a k consecutive days. So if my k was 2, then I could choose 2 consecutive days. So I choose 2 consecutive days here, right? And if I choose these 2 days, the problem is saying that I could set the strategy of the first k by 2 elements as 0. So I'll change this strategy by 0. And the problem says that I could take the last k by 2 elements and set the strategy of those elements as 1. So the last element, because k was 2, so k by 2 was 1. So the first one element I made the strategy as 0, and the last one element I made the strategy as 1. So now my overall profit would be 3 into 0 plus 4 into 1 plus 2 into 1 plus 4 into 1. This would be 4 plus 8 plus 2 is 10. So my total profit would be 10 now, if I perform this operation on this first sub array, right? Similarly, I could also perform, let's say, if the array was same, so 3, 4, 2, 4 and -1, 0 and a 1 and a 1. If I choose to perform the operation on this sub array, so I'll take the first k by 2 elements, which is the first k by 2 element is this only. So I'll make the strategy 0, which it was 0 anyway, so it will remain 0. And I could choose the last k by 2 element, and I could make the strategy 1. So this was 1, so it wouldn't change. And now I could take my final profit, which would be -3 plus 0, 0 plus 2 plus 4. So this is 3 again, right? This remains that of an original array, right? And now we need to calculate the maximum profit if we perform the operation on any of the sub array, such that it includes k consecutive days, right? So what this problem says, that if we have a large array like this, so we have a large array, and if my k was, let's say, 4, so if I choose, let's say, this array or this sub array, then I could choose the first k by 2 elements. So these first k by 2 elements, and I could make the strategy of first k by 2 elements as 0, right? And I could choose the last 2 elements. So I could choose the last 2 elements, and I could make the strategy of these elements as 1, right? So I'm saying that if we just slide the constant window of size k, so I start sliding my window of size k from here, then I choose this array, and then I choose this array, then I choose this array. So now we'll be able to calculate all of the possible subarrays that are possible in this array, right? Because k is not changing with time, so we'll have only limited number of possibilities for performing that operation, right? There's also one case where we choose not to perform any operation. So in that case, our answer will remain as it is, right? As the first one, or this one, right? I'm sorry. So if we choose not to perform any operation, then we will just multiply the prices of I with the strategy of I and take the sum of all the elements. I hope this is very obvious. So if I choose to not perform any operation, then that is pretty much sorted. Otherwise, we can calculate performing operations for all of the subarrays because k is constant, right? So we can choose to slide the constant window. And now let's see, if I choose to perform an operation on this subarray, then I'll set the strategy of first k by 2 elements is 0 and the last k by 2 elements is 1. So no matter what the initial strategy was, so if it had an initial strategy like minus 1 0 0 and 0 1, so no matter what was the strategy before, but now if I'm performing the operations, then I will exclude the first 2 elements, so I will not take them into account. I'll change the strategy of first k by 2 elements is 0, and I'll have to take into account the last k by 2 elements. So I'll take these last k by 2 elements and then I'll take them into account. So I'll add these values into my final profit, and this part and this part remains as it is, right? This doesn't change with if I perform an operation on this subarray, right? This part of the subarray and this part of the subarray remains as it is. So don't you agree that if I have a overall profit, and if I can subtract this, if I had a profit, overall profit, the sum of prices of I into a strategy of I, P of I denotes price of I and strategy of I is S of I here. So if I have a total profit, this is a total profit, and if I exclude the profit of this subarray, so if my original strategy was minus 1 0 0 1, then I could remove this from the total profit actually. So I could because this contributed what? If this was A1, or I'll write it here, if this was A1, this was A2, this was A3, similarly A4, A5, A6, A7, A8, and so on. So this was contributing minus A3 to my final total, right? Total profit. So in order to remove this, because we are anyways changing this to 0, right? So it was contributing minus A3 before. So in order to contradict this or cancel this, we'll have to add a A3, right? So this becomes 0, and now its effect is cancelled. Similarly, if it was 1, so it was adding up A6 to the final total, right? So in order to balance that, we'll have to subtract an A6, right? So this contributes a 0, this also contributes a 0. This anyways contributes a 0 because the elements are 0 itself. So now with that, we can neutralize this part of the subarray. If we choose to neutralize this subarray, then what we can do is take this, the second part, and we can add these A5 and A6 after neutralizing this subarray. So after neutralizing these array, I could this was originally doing a minus A3 on the total, so I'll do a plus A3 on the total, and this was doing plus A6 in my total, so I'll do a minus A6, and this was my total, so I'll subtract that from my total, right? And now my total value is or this part, the complete this part, the complete this left part, and the complete right part, excluding this subarray. So now we have neutralized the effect of this subarray, right, by doing this plus A3 and minus A6. And now since what we did is we neutralized this complete subarray, but we need to include the last k by 2 elements. So in order to include the last 2 elements, I could just add A5 and A6. So I could add these last 2 elements in the final answer, and this would be my total total profit for if I choose to perform an operation on this subarray, right? Don't you agree that? Because this is anyways changing into 1, right? The strategy is changing 1 for the last k by 2 elements. So I'll have to take into account the last 2 elements. So I'll take into account the last 2 elements. and the strategy of first k by 2 elements is changing anyways to 0, right? So I'm changing the I'm changing the strategy of the complete subarray to 0, right? I'm changing the complete strategy of complete subarray to be 0. So this is 0, this is 0. And how I can do this is that I could maintain a prefix sum, right? I could maintain a prefix sum of strategy of I into profit of I, profit of I. I could maintain a prefix sum, and then to if I from the total profit, if I choose to remove this part, so I could take the prefix sum of P of R minus P of L minus 1. So this will give me the prefix sum of this part, right? And I could subtract that from total. So I'll be able to neutralize. Let me choose a different color. So I'll be able to neutralize the effect of this subarray, right, on the total profit, if I choose to perform and subtract P of R minus P of L minus 1. So I neutralize this effect of this subarray, and after neutralizing the effect of complete subarray, we need to take the last k by 2 elements into account. We need to add these elements, right? So I could maintain another prefix sum. So this is P2 of I, which will be the sum of profit of I, because we need to add these elements in order of 1, right, or order of L or order of log n to pass the constraint. So in order to add the element in order of 1, what we do? We do a prefix sum, right? So we need to add the last k by 2 elements in order of 1. We need to add these elements in order of 1. So I'll maintain a prefix sum, simple, of these elements as well. And after neutralizing the effect of this complete subarray, I'll have to include the effect of the last k by 2 elements. So this would be my modified, let's call this L dash. This was R, and then I'll do a P of R or P2 of R minus P2 of L dash, or L dash minus 1 would be it, if this was L dash, right? Because we need to include the last k by 2 elements, right? So if this was L dash and this was L, right? So I'll need to include the sum of these elements, the last k by 2 elements. I know it's getting a little messier here, but I need to include the last k by 2 elements, right? So I'll maintain a prefix sum of this, because this was price, right? So I'll do a P of R minus P of L dash minus 1, right? So I'll subtract P of R, or I'll subtract a P of L dash minus 1, so this one, from P of R. So I'll get the total sum of P of R, or from L dash to R, right? I'll get this sum, and I'll add that to my total, and that would give me the final answer for this subarray. And I could do this for all of the subarrays. So after doing for this subarray, I could do for this subarray. I could do this for this subarray as well, and for all of the subarrays. And then I'll maintain a maximum, and I could take the maximum of all such cases, and that's it. That would be it, right? This was a very simple problem. I hope I was able to explain it to you. This would be the code. First of all, I'm maintaining a total by doing a prices of I into strategy of I. Then I'm creating two prefix sum. The pref sum denotes this is the first prefix sum of S of I into P of I. This is essentially that, P of I into S of I, and adding the last element. Then I'm creating a second prefix sum for all the prices in order to get this thing, add the last k by 2 elements. Then I'm calculating for all the I'm sliding the window for all of the subarrays. Also, if I choose not to perform any operation, then wouldn't be my answer would P of n minus 1, because I was creating a prefix sum anyways, right, of P of I into S of I. So I could just take the last element of that, right? So that would be P of n minus 1. And if I choose to perform operation, so I'll start from k minus 1, since we are taking 0-based indexing. If my k was 4 basically, so I'll start from 3 if my k was 4, right? Because we are taking 0-based indexing, right? So this was R. So L would be what? If I subtract k from R and add 1 to that, so R minus k plus 1. R was 3 minus 4 was minus 1, and I'll add a plus 1 to that. This would be my L. So L equals to R minus k plus 1. So this would be my complete subarray or subarray for this operation, right? Then I could neutralize this subarray by getting the profit sum of this subarray, and we can subtract that from total. So total minus and P of R minus P of L minus 1. So we can subtract the subarray sum or profit sum of this subarray, right? That's what I'm doing here. I'm doing a P of R, and if my L is greater than 0, obviously L shouldn't be 0. If my L is 0, then I could just take P of R, right? But if L is greater than 0, then I could subtract L minus 1, So this is P of R minus P of L minus 1. I'm neutralizing the effect here, and then I'm doing a plus equals to K by 2 if my K was 4. So if my L was 0, I could, K by 2 is 2, so I could increment K by 2. So my new L is this one. And I need to take into account these last K by 2 elements. So I do a P2 of R minus P2 of L minus 1. So I'll add these elements into my total, right? So P2 of R minus P2 of L minus 1. That's what I'm doing here. P2 of R, or this was initialized with pref and my current code, and I'm doing minus P pref of L minus 1, and then I'm subtracting, neutralizing the effect of the first thing, the first profit sum of that subarray, and then I'm adding the last K by 2 elements, and I'm taking the maximum. I'm returning the answer. That's it. This is the code for this problem. I hope you got the general idea of how to solve these types of problem, because essentially this was just prefix sum, right? We'll have to get the intuition of how it was prefix sum. If we'll think about this, like, right, like we can only perform one operation and K is fixed. So that means how many possibilities do we have? We can consider all of the subarrays, and if we want to consider all of the subarrays and K is constant, that means we can slide a window of K on all of the subarrays and we can calculate the answer for all of the subarrays. Take a little time to digest this, but I hope you really got this. Anyways, I'll see you guys in the next one. Thank you for watching, and Radhe Radhe.